Keep your laser more.
Pew pew.
I haven't shown this much on my channel, but this is my Elekslaser A3 Pro. Today we're going to change out the laser unit for something slightly beefier. Let's take a look. While my little laser treated me well and did exactly what I wanted to do, perhaps primarily just cutting some gaskets out and templates and basically paper-based stock, I want to move up to something a bit more substantial. So I've got this puppy. Now this is the Sculpfun S9, I believe, and I'm going to upgrade the laser and we'll be burning holes through retinas in no time. So the main idea, I have already opened this up, so it's not really an unboxing. I'm just going to show you what's in the kit. I've got a little toolkit and some fasteners, a adapter plate by the look of it. The business end looks pretty cool. It's supposed to have a fixed beam laser with minimal convergence. So this is about all you get in the kit. Some fasteners, a mounting plate, the laser itself, and the height gauge, which presets the height on the material you're going to engrave or cut. Okay, let's see how it all goes together. Okay, let's take away the boring bits and have a close look at this puppy. Sculpfun Model S9, made in China, and all the requisite warnings. Maximum laser power apparently is 5.5 watts. Don't know, see how we go. But it does say it's got a 12 volt 3 amp input. So in my book, that's 36 watts. So 36 watts input power, 5.5 watt output. Apparently it can cut up to 15mm plyboard. Yet to be seen, but who's doubting? We'll see how it goes. On the back is the driver board, a simple 3-pin JST connector. You can just see it's 12 volt plus minus and PWM signal to control the intensity of the laser. Generally, it will drop straight into any Gerbil or GRBL powered CNC setup, probably more as well. So if your setup can deliver 12 volts as well as a PWM signal, this laser will more than likely work on your machine. Your setup may vary, but this is going on the Elekslaser A3 Pro. As you can see here, this is the Bernie end with its own little perspex or acrylic filter shroud. By no means this is your ultimate protection. You should still wear your safety glasses and whatnot. But the standoff from the workpiece is only 20 millimeters. And if you look at the stand, I just threw that away somewhere. The way you set this up against your workpiece, you put the stand between the aluminium heatsink and the work. You can see there, it's only about 3 or 4 millimeters off the work. So there's not much chance, unless you're looking down parallel with the workpiece, there's not a lot of chance to see the actual raw laser beam and or the work actually engraving. So not too bad. It's quite close to the workpiece. I'm no way responsible for loss of eyesight. Just a quick shot of the spec label. Okay, the hardware that comes with the kit is this backing plate, which suits the laser module itself and allows you to adjust the height. A couple of brass standoffs, 4 M3 screws that look like they're about 40 millimeters long. Let's have a look, maybe 30. Yeah, call it 30. A couple of thumb screws that allows you to height adjust the laser module. Some rather large diameter M3 washers. This chunky double open-ended spanner or wrench or whatever you'd like to say. 7mm one end, 5.5 the other, and rather thick. They will fit these nuts here as well as any hardware that is on the existing machine. And again, as mentioned earlier, 20mm spacer to set your height and the ubiquitous Allen key. Oh, and you also get a 1-page back and front instruction manual for basic fitment. So this is the overview of my Elekslaser A3 Pro, and we're going to take a closer look at the current laser module on this system and then the new one and see what changes we may have to do to get this unit upgraded. So a close-up of the original unit here on the left and the replacement unit on the right. We can straight away see that we have a JST connector for the power and signal, whereas on the original unit the yellow wire is the signal wire, which is directly soldered to the board, as well as just off to the side here, we've got the positive and negative for the power delivery to the unit. So straight away we can see that it's not a straight swap as far as the electrical connections are concerned. We may need to make a new cable with JST connectors. Some of you may be able to do that with tooling on hand, but for the general population, I guess, you would have to consider either making a JST connector to meet this, or on the other hand, desoldering this socket here and hard wiring in the unit. If it's going to be your forever unit and you're not going to keep swapping in and out, then that's okay. But if you are in between certain laser units for doing certain types of work, depending on your workflow, I guess, this would be it would be better to maybe implement that socket. The next trick is implementing the mechanical mounting of the laser. Now, this unit comes with this backing plate, which mounts this way, and it should utilize the original acrylic plate or whatever plate that comes with your machine and pick up certain screw holes on the back. Fortunately for this unit, it does appear, looking from the back, there is a few extra options for holes and mounting, and then this would become the de facto mounting option for this unit. Once this unit is mounted on the laser itself, on the carriage, this unit does fit on the back with some thumb screws to adjust the height, depending on the height of the material you're working with, to allow easy adjustment. It does appear the supplied wrench that comes with the unit may or may not fit. There you go, may not fit in behind the unit to hold these nuts on the other side of this mounting plate, so you will have to find another option. This Elekslaser platform is certainly not virgin. I've upgraded the laser previously from the original one that shipped, which was this 2.5 watt unit. And the dimensions, if you look at where the laser is centered as opposed to the back plate, it's very similar. So if I just place this here, you can see the bottom of the laser orifice here and the focus ring is pretty much the same in line with the original unit. But unfortunately it's not really unfortunate, but keeping in mind is the new unit will force you to sit further out because of the mounting block on the back here. So you can see straight away that we've probably gained, there's probably a good inch that the unit sits further out once it's fully mounted, which will cause the laser head to crash into the front frame if you're not careful. Just something to consider. Not a game changer, but another thing to look out for. So what we'll get to now is separating and removing this laser unit and then preparing to mount the new Sculpfun S9. Okay, so we'll remove the power supply and signal cable. It's just a 3-pin JST connector, and this is the only electrical connection for the unit. So with the laser module removed, we can see there's quite a lot of options as far as mounting is concerned. So what we'll do, we'll quickly take off the backing plate off the S9 and we'll see what would be the best option. I'll set that aside. We can probably see, we can mount this quite high, given the bottom row here, and that will still give us plenty of adjustment for whatever material we want to use. So we'll just make sure that that the slide can actually make, oh yeah, that seems to be fine. So to about there, which will give us nearly full depth. So we'll probably use these two middle holes and this middle section on the backing plate here, and then we'll go from there. If we have to change it, it's not too big of a deal because we just take the laser module off and just relocate between any of these slots and any of these holes. So plenty of options. Also, just a side note, you'll notice these two screws in the backing plate. That actually attaches this block. So this block can be relocated up or down depending on where you need it mounted. But for this mounting option, we'll just leave it where it is. Taking 2 of the 4 M3 supplied screws, being 30mm long, they should fit through the backing plate and the included block and protrude far enough to take up the acrylic backing plate with a little bit of thread left over. I'll just change camera position to show you what we're dealing with. So as you can see here, there's about 2 or 3mm of thread sticking out, so barely enough for the nut itself to go on. So the 2 supplied nuts do have washers, or a washer face. So we just pop that in there, mind my fingers. I'll just try and spin that on loosely. There we go. So you can just see, there's just enough threads for the unit to grab and start fastening. It's certainly not ideal. The engagement's certainly not full depth. So for the sake of this video, I'll continue, but it would be wise to probably get some 35mm long bolts and fully engage those retaining nuts there. Just ever so slight. Just be aware that these are cheap and nasty stainless steel screws and I will round out pretty quick, coupled with the fact that it's a cheap, nasty Allen key. it won't take much to round them out, so they don't need much. So now it comes time to mount the actual hardware, which is the laser itself. I can already see an issue, especially if you've got big hands like me. The space between the acrylic backing plate and the mounting plate for the laser itself is fairly tight. So even to get a finger and a thumb in there to loosen and tighten the thumb screws that come with the unit for adjusting the height is going to be problematic. So I'll try and do this in one take and just see if I can manage it. So we'll just slide the unit on top. Try and find the hole and locate it in the back. So if you move the unit down as far as you can, you do gain more access from this portion underneath the acrylic plate, but the problem becomes more realized when you're trying to move the laser up to a point where to fit the material in, but the thumb screws exist between the backing plate and the acrylic plate, and then things get awfully tight. So they only really need to be pinched ever so slightly. So if we do loosen them, how far down does the laser go? All right, that's at its full extent. Okay, you can't really see that, but we'll move the laser back. And I can just barely fit my finger under there. To give you an idea of the height, we don't quite make that remaining gap. So I think mounting it across that middle slot seems to be a good compromise, because we can still fit a 3mm piece of MDF under there, but we still need to adjust up slightly to fit our little height gauge in. So if we loosen the lock nuts at the rear, and we'll slide the stand in there, and then we just tighten them up. So that's basically how we set the height. Sorry for blocking the light there. And then that's done. So as I said, it can be and will be problematic if you need to set higher laser heights, because if you've got bigger hands, you're going to struggle with those lock nuts. You may need to, or the thumb screws I should say, you may need to use some long nose pliers just to give them a bit of a tweak, rather than try and get your hands and thumbs in there. We can see that the unit just glides beautifully, and the laser module itself is stable. It's definitely rigid enough for what it's got to do. And now we have to wire up the unit. Okay, one of the last things to do to fully set this up is take our power and signal wire, which is a 3-pin JST connector, and route it over to our laser, making sure we can still maintain full range of motion without getting bound up by a short cable. I think the stepper motor cable is okay for this. So we just need to make a new 3-pin cable for the control of the laser module itself. Through the magic of editing, quickly knocked up this cable, which will supply power to the laser unit from the control board. Now, there's a little bit of speculation in regards to these type of JST connectors and the size of the conductors. My belief is they're not going to provide 36 watts, not without large voltage drops. Now you might notice once we start testing that as soon as we start a high power laser event, the fan, you may hear drop in RPM or change pitch. That sort of signifies that we're not getting enough power delivered from the board to the laser module. That could be a couple of factors. It's not only the cable, but the way the power output is wired on the board itself. If we're only relying on a few little tiny traces to deliver the 12 volts from the power pack, the power brick rather. Now the power brick's rated to 5 amps. It doesn't mean that 5 amps is fully available to the whole unit. So we may need to do a slight mod to this to make sure we're getting the 12 volts. So it's only the positive and negative cables. The signal cable is just a signal cable which doesn't deliver any significant current. So it's only really the red and black. We're going to try this for now and see how it performs. But if we do have noticeable drop in the fan speed or the pitch changes, we probably suspect that we're not getting the power required to the laser, which is going to affect performance. So let's plug it all in, fire it up, get underway with some first tests. Before that though, I will make note that what I've just explained, where the fan speed drops pitch and changes speed during high laser output events, this laser actually did that as well. So that leads me to suspect that these cables aren't big enough, or the power delivery side of the circuit here isn't beefy enough, and we're getting quite high voltage drops. Now the cable I have used here is definitely larger. I couldn't tell you what gauge it is, but it's almost twice the size. I don't know if you can see that, but we'll test it out anyway. But I think our limiting factor is going to be the way this JST power connector is wired on the PCB. Okay, let's plug this module in and then into the power board or the control board. Now I have got the wires, I've double checked the wires and made sure they're the right way around, because I did confirm that with the previous unit to make sure that when the cable's in the right way, we've got a yellow, black and red and yellow, black and red. And the markings match the PCB as to the power output or input. Okay, so now we need to reconnect our stepper motor. Now please do this when there's no power attached to the unit. Unplugging, reconnecting stepper motors while the unit's powered, it's going to kill your drivers. And then you're up for a new driver. Yes, they're ubiquitous and cheap, but save yourself the hassle. Make sure you power down, and any parasitic voltages or even unplugging the power brick will definitely be in your favour, because even parasitic voltages left in the system can cause voltage spikes that will destroy your stepper motor drivers. Okay, well that's just loosely wrapped up that cable, and we can just confirm we've got the full range of motion. Seems to be fine. Now, just be aware, because this protrudes out further from the main mounting plate, you are going to risk crashing it to the back of the front bar. So just be aware of that. You will lose a little bit of travel, but it's minor. It's about 1 inch off the full travel. But, you know, you can always extend the chassis. These Elekslaser modules are, Elekslaser platforms are modular, and you can extend the side rails to give you more depth and whatnot. So you can make it as big as you want technically, but it's not a major issue in the grand scheme of things. Okay, so it looks like we're all wired up. So I'll dig out the laptop and do the jazz hands routine on the keyboard and see if we can get this fired up. Hopefully it all goes well. It's always handy to put a bit of sacrificial material underneath the laser. And one side note, always plug in the controller to your USB first before turning on the power to the laser, because sometimes the boot up sequence will supply a PWM signal to the laser, which will cause a full power firing randomly during boot up. So I always tend to power up this unit first via the USB and then turn on the power to the laser. Handy tip. Ask me how I know. Okay, everything's wired up and appears to be all working. I've got an orange on light on the top of the unit. Probably can't see that. Okay, everything's wired up. I've got a little fan here just to blow away any smoke that's produced. Well, if it works. The unit has an orange light up on the top here. You probably just can't see it on camera. So that's an indicator that it's got power. Fan sounds good. Okay, small program ready to run. I'll hit start and we'll see what happens. It's only running at about 50% power, just so I get a feel for the laser itself. And I'll just let this run through and I'll speed the footage up. So that last engraving was done at 3000 millimeters per minute. This test is going to be done at 6000, so just doubling the speed, and on top of that, this is 6000 is the maximum program speed of this Elekslaser platform. So we'll see how it goes. This video was intended to show the fitment of the Sculpfun S9 Laser Module. It is a 5.5 watt unit. Whether or not it is actually a 5.5 watt output, who knows. We'll be doing some more tests later on in the piece, but at the moment this is just showing the fitment to the Elekslaser A3 Pro. It is a capable and quite fast platform, so you can get up to 6,000 millimeters per second travel speeds. And with that much power, you may need those speeds because laser engraving is speed and laser power hand in hand. So you do need to do your testing to find out what your machine's capable of. The testing I do for this unit doesn't necessarily translate to another unit like unit. There's different tolerances in the laser diode and the platform itself and the software you run. You will get differing performance. So my numbers that I produce may not exactly work on your machine. There will be some finessing and some adjustments needed to get the results you want. So hopefully this has been a fairly informative video, hopefully not too long. And down the track, I'll get into some other projects again. Stay safe and happy lasing. See you next time.